Hi Math 95. In this video we're going to introduce section 10.2 where we discuss what are called rational exponents. So we've worked with exponents before, but now we're working with a new kind of exponent. We're working with a rational exponent. So far we've seen integer exponents, exponent of 2, exponent of -2, things like that, but now we're going to use rational numbers. These are fractions, right? So we're dealing with fractional exponents. Rational exponents are defined so that their properties are the same as when we were using integer exponents. So what that means is all the properties and our fluid concepts we have with integer exponents apply still when we're using rational exponents. So we're going to look in this section for what it means when we're actually using a fractional or rational exponent, and then also how to simplify. So let's start out with a definition. So let's first start out with a definition of what an exponent of 1 over n looks like and what it actually means. So if we have the nth root of a, that's going to be our notation for what a to the 1 over n means. It's going to represent the nth root of a. Okay, so really what this is telling us is that fractional exponents are directly connected to radicals, right? So before, where we had just integer exponents and those meant just repeated multiplication, here when we have a fractional exponent we're actually working with radicals or roots, right? So a couple of things here. If you have a radicand, the thing sitting inside of the radical, if that's negative, the n has to be odd. The reason is because remember that if you have a negative number living inside of the radical, you have to be taking an odd root. If a is non-negative, meaning either positive or 0, n can be anything you like. It can be even or odd. It doesn't matter. Okay, so let's look at a couple of examples here. So the few examples we have are, the first one's kind of complicated actually, but the other ones should be a little bit easier to digest. So just practicing with the notation here, notice this says that we're taking some expression and raising it to the 1/5 power. That means, remember, since this is a 1/5, that we're looking at a fifth root, right? It's 1 over n is 5. So that means we're looking at a fifth root of whatever is inside the parentheses. Okay, for the second one we have 100 raised to the 1/2 power. Okay, 1/2 means that the n is 2, right? If we go back to our slide here, the n would be 2 in that fraction for the exponent. So we're looking at a square root here, namely. So here we're looking at the square root of 100, which is 10, right? So what that means is 100 to the 1/2 power is really 10, or the square root of 100. Okay, -64 to the 1/3, notice that the negative is inside of the parentheses, so it needs to live inside of the radical, and the power is a 1/3, so we're taking a cube root. So the cube root of -64, which is -4. All right, so let's now make this a little bit more complicated here. So instead of just looking at an exponent of 1 over n, like we were just a second ago, we're instead going to look at what happens when you have an exponent of m over n. Well, because of our properties of exponents, we know that there's two ways to actually interpret this. Because this power of m over n, this fraction here, could be written as m times 1 over n or 1 over n times m, right? Either one of those two things. It allows us to interpret this fractional exponent here as either one of these two radicals. Either the nth root is taken first and then you apply the power of m, or you apply the power of m to a and then you take the nth root. Either one of the two. So let's see what an example would look like. So in this example, we're taking 25 and raising it to the 3/2 power. So again, there's two ways to interpret that. Either you can see that that means you're going to be cubing because of that 3 in the exponent in the numerator right there in the fraction. You're going to be cubing, and because there's a fraction here of a 1/2, right? 3 times 1/2 is 3/2. You're going to be taking a square root at some point too. Okay, so they've chosen to write the square root first, so we're going to do the square root, which is writing the 1/2 power, and then you take that result and raise it to the 3rd power, right? So that means here it's the square root of 25, which is 5, and then you cube that, which is 125. Okay, let's look at the next one. So we've got -27 raised to the 2/3. Again, there's going to be a cube root happening somewhere because that 3 in the denominator, and there's going to be a squaring happening because of that 2 in the numerator. So what did they decide to do first? It looks like they decided to do the radical first, right? Again, if you remember our slide, we've got choices here, right? They're in general using this first one where you're using the radical first and then raising to a power. So they're taking the cube root of -27 first, which is -3. Notice the remaining parentheses here. The reason is because you're squaring a negative number. You want to square the whole thing that was in here. Square all of -3, okay? When you square -3, you get 9. In general, by the way, it's more beneficial to do the radical first and then do the whole number exponent on the outside like that, right? In general, this first one is a better choice to do. The reason is because by applying the radical first, you're making the number smaller and then making it larger, right? So you're dealing with making a number smaller and then larger versus in the second option down here, you would be taking a and raising it to m, right? Which would make it a big number, and then you're trying to take a root of that of some kind, which might be more difficult. Okay, so in general, the radical first. Let's consider another specific instance of a rational exponent here. And the last case is here where we have this m over n exponent, but now there's a negative out front. The property here works just the same way it did when we had integer exponents. If an exponent is negative, it just means that that expression carrying the negative exponent wants to be on the other side of the fraction, right? So currently this thing lives in the numerator, it wants to be on the other side, so you move it to the denominator and you drop the negative on the exponent, and you still have the m over n, or m divided by n, or the fractional exponent there. You've just dropped the negative because you've moved it. And once you've moved it, you just deal with the a raised to the m over n like you did just a second ago, right? So just apply the negative for the exponent just like we did with integer exponents. Okay, so let's just, if you've forgotten them, do a little recap of our properties of rational exponents here for a second. All of these properties come from when we worked with integer exponents, but they now apply to when we're working with rational exponents as well, right? So if we're multiplying and we have the same base, we add the powers. If we're dividing and we have the same base, we subtract the powers. Okay, these ones should be fairly common to you. If you have a base raised to a power raised to a power, what do? You multiply the powers. This is the product of powers rule here, where you have if there's a product acting inside of a power, the power can apply to each one of those factors in the product. Same thing goes with division. If you have a fraction living inside of a power, or a power acting on a fraction, then the power can act on each the numerator and the denominator individually. All right, so let's just do a little important things to remember here. The properties that we have for integer exponents, they're true for rational exponents, right? So everything that you know about exponents, they still apply here. Even if you have a negative exponent with a fraction up there, it's still going to apply using the same rules. Okay, and lastly, we consider an expression that has rational exponents to be simplified when the following happen. There's no more parentheses, there's no powers raised to powers, bases occur just one time, and there are no negative or zero exponents. All right, so I will be posting the answers to our practice set for 10.2 that I handed out in class, as well as the answers to the other ones that we did in class together. But make sure you're checking your practice problems for 10.2 to be sure that you're applying these rules correctly.